In this video, we are going to see how to construct a DFA for the patterns that ends with for the string that ends with some pattern. Okay, for example, we'll see how to construct a DFA to recognize all strings over 0, 1 ending with 1, 0. So the pattern, that is the all automata, must be able to generate strings that ends with the pattern 1, 0. For example, the strings recognized by the automatas will look like this, right? So as usual, as we did for the substring, here also first we'll construct automata for the pattern that we'll consider as the basic one. So here the 1, 0, so I've created 3 states and we'll accordingly connect it. Now, since it is a DFA, we have to give transition for every input symbol present in sigma. So here for the state A, we have transition for on the input symbol 1, but the transition for 0 is missing. So as usual, we'll try to introduce self loop. If we introduced a self loop here, then what languages does this DFA generate? It generates strings like this: 0, 1, 0, 0, 0. So anyhow, how many number of times do I repeat this loop, I'm getting a string that ends with 1, 0, right? Hence this transition, that is this edge, is a valid one. Next, when we check the state B, here we have transition for input symbol, and transition for input symbol 1 is missing. So as usual, introducing a self loop for the input symbol 1, it generates a string like this. Again, when we observe the string, all the strings generated by this automaton ends with 1, 0. So hence no problem, we'll retain the transition. Next, for considering state 3, there is no transition for either of the input, that is 0 and 1. So we have to introduce transition for both 0 and 1. So when I introduce a self loop for 0 and 1, what happens to this? So it does not generate. So when we observe this string generated by it, because of the presence of a loop here, this loop may repeat 0 and 1 or 0 or 1 n number of times, which leads to a string that does not end with 1, 0. Hence, we should not have a self loop. We have to find an alternate for it. Right? So again, to find an alternate transition for the input symbol zeros and ones, what we have to do, we have to try for since there is no forward, there is no vertices after this vertex C, that is state C, we have to see for the forward transition. So checking like that, yields a DFA like this. So this is a DFA that's end with the pattern 1, 0. So when we observe this, when as compared to a DFA that we constructed for recognizing substring, what difference do we observe here? See here in substring, both the starting state and accepting state is allowed to take a self loop. But in case of DFA that ends with some pattern, what the self loop is allowed only in the first state, that is in the starting state, right? Then we cannot have a self loop in the ending state, that is the accepting state, because here we have to construct a DFA that recognizes a string ending with some pattern.